Welcome and thank you for being here today. Our project focuses on a critical yet overlooked issue, the filtration and recovery of nanoparticles from liquid waste, but we have a big emphasis on the actual recovery of these nanoparticles. And the big problem is the actual environmental impact, right? Nanoparticles, they remain in the ecosystems, harming the aquatic life, the fishies, and there's also the human health risk when we're drinking or even in water contaminated with nanoparticles. It can lead to different respiratory and cardiovascular diseases, and there's the economic loss, right? For companies losing these valuable nanoparticles that are being accidentally tossed down the drain, this could lead to inefficient disposal process. And then finally, we have the actual challenges themselves with nanoparticle filtration, which the basic ones are the size, diverse chemical properties, etc. And there are existing solutions like ceramic membranes, but they're costly and also lack scalability and often prevent the actual nanoparticle recovery, which allows us to have an opportunity to innovate, which leads us to our defining question. How might we use selective filters to separate and remove a wide range of varying harmful nanomaterials from liquid waste or for reuse or disposal to increase safety, limit environmental damage, and decrease costs?
So that defining question leads us to our objective, which is to create a practical, versatile, and scalable solution for nanoparticle filtration, separation, and recycling in research and industrial applications. Now, in order to reach this objective, we went through several ideation processes, including Wander, reverse brainstorming, idea suspension, and crazy eights. So the solution that we were able to get from that was that we are going to develop a nanofiltration device that utilizes a series of dissolvable polymer membrane-based filters to separate materials from a liquid suspension. Now, the dissolvable or diffusive filters will facilitate nanoparticle recovery and/or repurposing. Ideally, the filtration will be rapid and effective in nanomaterial removal. So as for the functionality, as you can kind of see on the right here, we have an image of the proposed design. So this design will use polymer membrane filters to separate different types of nanoparticles based on their properties. And the two types of filters that we're focusing on are carbon nanoparticle filters and metal nanoparticle filters. And as you can see on the right, we kind of have two filters there, different colors distincting the two different types of filters. Now, centripetal force, the magnetic stir bar in the middle, will push the solution over the filters so that the filters can absorb the particles. And then afterwards, those particles can be dissolved or desorbed in acetone or HCl solvents and later evaporated in order to recollect or dispose of the solid nanoparticles.
The control of our experiment will be an untreated polycarbonate filter in the solution with nanoparticle suspension of both carbon and metal nanoparticles. And this will be used as a baseline to determine the filtration capacity of our membrane filters. And the next step is to run pre-experiments with the individual filters to ensure particle filtration selectivity and efficiency in filtration. And to determine this, we will run 12-hour experiments, taking measurements of concentrations every hour, and use the UV vis to determine the particle concentration, and then also an SEM to image the membrane pore morphology and size before experiments. And then after each pre-experiment and official experiment, we will use the SEM to evaluate membrane morphology to determine membrane strength during filtration. And to determine overall filtration capacity, both filters will be placed into the system with the nanoparticle suspension. And to ensure 99% of particles can be filtered, concentrations of the solution will be collected every hour for 12 hours to determine rate of filtration. And then finally, to collect the absorbed material, membrane dissolution or desorption in a basic solvent, dissolution acetone and desorption in 0.01 molar hydrochloric acid will be used, and then product recovery will occur after low temperature evaporation of the dissolved membrane or physical removal of the membrane itself. Thank you for listening to our presentation and have a lovely rest of your day.